Hi guys, welcome to my YouTube channel. Today my topic is related to the applied calculus, in which we will discuss about the rate of change, uh, about the relative change of the functions. So that we discuss the average rate of the change. We have a lot of examples and graph in this, and we will also discuss this example at which the rate of change and its formula is given. You can see all. So, what is rate of change? In the previous section, we saw that the height of the winning Olympic pole increased at an approximately constant rate of 2 inches a year between 19 and 1912. Similarly, the world record for a mile decreased at approximately constant rate of 0.4 seconds a year. We now see how to calculate rate of change when they are not constant. So the example one about the rate of change is that the height of the winning pole and the wallet and the Olympics during the 1960 between 1960 to 1968 and between 1992 to 2000, in which these two periods did the height increase faster than during the period in 1900 1912, and from 1900 to 1912 the height increased by 2 inches per year. To compare the 1960s to 1990, we calculate the average rate of the change of height, where a change in height and a change in time. Then when we calculate the 3.5 inches per year is the answer. So during thus an average and the height was increasing more quickly during the 1960s from the 1900 to 1912. During the 1990s, the height was increasing more slowly from 1900 to 1912. For example, the function does not have a constant rate of change. However, we can compute average rate of change over an interval. The world average is used because the rate of change may vary within the interval, and we have the general formula that if y function of t, so that y is equal to f t, then average rate of change is equal to y between the t is equal to a and the t is equal to b. The unit of the average rate of the function are unit y and the unit of t, and the average rate of the change. The linear function is the slope and the function is linear if the average rate change is the same for the all interval. And the second example is also given that estimate the average rate of the change of the numbers of farm in the US between 1950 to 1970. This figure shows that the number of n of the farms in the US was approximately 5.4 million in 1950 and approximately 2.8 million in 1970. If the time t in Israel, we have the average rate of change del n by del t, where 2.8 minus 5.4, and in 1972 and 1950, and 0.13 million farm per year. The average rate of change is negative because the number of farms is decreasing during this period. The number of farms decreased at average rate of 0.3 million per year. And example 3 is the high level of PCB as the industrial pollutant in this environment affect the eggs. As the concentration of PCB of eggshells increases, the thickness of the eggshell decreases and making the egg more likely than break. So the table is given. The units of thickness over PCB concentration unit or millimeter over parts per million. The average rate of change is negative because the thickness of the eggshell decreases. As the PCB concentration increases, the thickness of the Welschen eggs decrease by an average of 0.008 millimeter. Visualization rate for a function y is equal to fx. Change in the value of the function between x is equal to a and c